Hello, everybody. Welcome to the inaugural Innovation Briefing podcast. We're really excited about launching this podcast and videocast with themes about the digital transformation of the world. And we're going to discuss emerging trends in technology and their application in different vertical markets. We're going to talk about how these digital technologies are going to transform the world. We've seen massive transformation so far, but we're only really at the beginning. And we're going to look at the business side, the technology side, the operating models. But the underlying theme is how emerging technologies are going to in the future transform business models. We've already seen massive transformation, but every industry will get transformed. We've only seen the early stages of that transformation. And in our inaugural podcast, we're really pleased to have Patrick Bangert from Samsung, who is the head of AI, and we're really pleased to have him here today. Hello, Patrick.
Hello, Alpesh. Pleasure to be on the show.
Fantastic. So, obviously, let's do the normal stuff. Let's get an introduction from you and about your background. I'd love to hear about where you came from. So one of the things for me I always like to hear about is how did you get where you are from where you've been? You know, it's always interesting for me when we're talking to people is, you know, how did you get into this world and what's the origins of getting into the area of AI?
Yeah, thank you. It's a great question. So I started out as a German boy, and my father was interested in astronomy. So I looked at all those beautiful pictures. And so when I graduated from high school, I went to the physics department at University College in London, actually. And I quickly learned by doing the usual experiments in the laboratory that was not for me. Laboratory experiments generally don't work. They're very frustrating. And so I'm more of a theorist. I like equations and numbers and paper and pencil work. So I switched to the mathematics department at that time to do my PhD work. And there I got introduced to neural networks, which at the time, this is the late 1990s, neural networks were not in favor anymore. That was the AI winter, as they called it, because the networks didn't deliver. And but I got interested in them, and I did some work with them. Ended up getting my PhD. So then I spent some time myself as a professor of mathematics in Germany, but I quickly figured, as an applied mathematician, in order to actually apply the mathematics, if you will, I can't do it at the university. So I started my own company to take some of these methods to the industry. At that time, it was the oil and gas and chemicals industries, to do things like predictive maintenance or optimization of the plants. And that's how artificial intelligence, for me, came together and resulted in a practical application that made people's lives better in some sense. And of course, along the way, the AI winter stopped because of what we now call the deep learning. That came about. And the principal innovation there is that we figured out as a community how to train neural networks that had more than one of these so-called hidden layers. And that's what makes a network deep, right? If you have more than one layer, it becomes deep. That's how deep learning is effectively a recasting of what used to be called neural networks in the old days. And then after my startup, I got recruited by Samsung to be the VP of AI here at Samsung SDS America, where we are in the Silicon Valley, trying to drive AI at the state-of-the-art forefront.
So that's an interesting history. You know, I've had a similar history to you. You know, I wrote my first neural network before you did in 1990, and it sort of shows my age. You know, and the challenge at the time was the computational power just was not available. So the theory behind neural networks has been around since the 60s. But the practicalities of implementing these things, and as it's now called deep learning, and we can talk about phrasing and branding in a bit about that. You know, how do you see the evolution of that? You know, when did you see the crux point between having all the algorithms like neural networks and seeing now it's practically possible to get tangible results in a real environment, because that's the thing, right? Being able to implement that in a real environment to solve a real problem and productionize it. When did you see that crux? Was there a inflection point, a time, a technology? What was it that you saw that actually now we can do it?
Right. So it was really three things that came together. On the one hand, you needed the faster processing, which included things like faster CPUs, that at some point these so-called graphics cards, what today are called GPUs, came about. So faster hardware, that was definitely one aspect. The second aspect was availability of larger data sets, which has something to do with sensor equipment out in the field. And the third component was, of course, some little bit more mathematics. So the mathematics we use today for what's called deep learning is very similar to the 1960s mathematics, but it's not identical. There were a few innovations in mathematics that helped as well. These three things came together, and it's really in the early 2000s, around about sort of 2005-ish, that these three things converged at the same time, and we had all three of them available simultaneously to be able to come up with these networks. And then, of course, the fourth element that allowed us to transport these networks and the results to the general public is the internet. Without access to the internet and fast data channels throughout the world, you wouldn't be able to get the data into the network or the result out of the network. So you needed all of these things to work together. And of course, they were not accessible in the 1960s. And therefore, back then, the mathematics did not work out in practicality as it should have.
So that's fantastic. I think the other element for me is, okay, well, how, what were the early stages of companies realizing that they could use this? Because most companies have still, we're in 20, we're in a massive in 2021 in this podcast. When did companies realize that they could actually do something with this stuff? When did you see, oh God, we can use this tech and it can solve a bunch of problems? When did you see the early stages of that?
Right. So there were two waves of this. One wave happened in the early 1990s, where mathematicians who were enthused about the neural networks that they had went to a lot of commercial companies and said, neural networks can solve everything. And companies loved it and they bought it. And those neural networks, of course, famously didn't work.
Yes.
And that caused what's called the AI winter, which dropped funding and dropped adoption in AI technologies very severely in the late 1990s, early 2000s. And then the deep learning, quote unquote, revolution came and made things more available, more accessible. And again, the mathematicians went around to all the companies and said, no, now we're serious. Really, neural networks can do everything you want. And the companies now were really cautious because they said, okay, we tried this before and last time you lied, or it just didn't work out, So it was really, I think, the retail industry in multiple dimensions that was the first to really pick this up and implement this for real. So if you think these days about the price you're paying for an airline ticket, the movie that you see on Netflix, the book you get recommended to buy on Amazon, all of these things, these are AI systems that work in the background. Of course, you as a consumer don't realize that this is AI doing things for you, but it is. And so it's this retail business that really drove it. I gave a few examples to the forefront and the back front as well. So, for instance, if you have a chain of stores, how many units of a particular product do you ship to each one of the stores? And at what time? You need to have an expectation of how many units you can sell each week at each one of your stores globally. That's, for example, one of the applications that Samsung does. We have over 10,000 stores selling mobile phones in every country in the world, and we have to decide in advance how many of these phones to ship to each one of them. We don't want to run out, but we don't want to have a storeroom full of unsold phones either. So you kind of need to get it right. And that's a complicated task because it also involves things like special holidays of that particular country and the behavior of people in that country and so on and so forth. So there are back office applications to AI in the retail industry as well. So all these kinds of things, I think they happen first. And at the current time, it's the retail industry that has really commoditized AI. If you are anything to do with retail, you better have AI, or you will be seriously behind your competition.
So that's an interesting point. You talked about how AI is applied in Samsung. Is that in things like logistics and supply chain, in manufacturing, in distribution, in market assessment? Are you talking about it applying to every part of that supply chain?
I'm literally talking about every part of it. So just very briefly, for example, we have defect detection in our wafer manufacturing. So that's the earliest stage, right? Samsung makes its own chips, which is a silicon wafer. That's assessed by optical technology. So literally, we take a photo of the wafer, and the AI decides whether the wafer is functional or not. Then that continues throughout the manufacturing process until you have a phone or a laptop made. Then, of course, we have models deciding where to ship it. Which storehouse, which store it's going to be sold in at what time. So we also have a planning utility that tells us how quickly we need to manufacture each item. Then we have models that regulate the sales representative visits to stores, right? Our sales reps are not at every store all the time. Mostly we sell via third parties, like Best Buy and things like that. So our sales reps go there, at the appropriate time. And what is the appropriate time? Well, it's the AI's job to decide. Then we try to fulfill the sales plan that the AI came up with. So it is indeed the entire chain: manufacturing, distribution, supply chain, sales, and marketing. We email out marketing materials. We post marketing materials all over the internet, and where it goes and when it goes there and under which search terms it's reachable, that's decided by AI. So AI is involved in the entire chain. And the crucial thing, I guess, to realize on an AI level is that this isn't one AI that's doing all of these things. AI is a very specialized thing. And so what I've just said includes about 20 plus completely separate models, designed differently, designed separately, deployed differently, running on different computers and different data centers. So when I say AI does this, that's a very loose formulation, because it needs a lot of projects to be done quite separately from each other.
So that's an interesting point. If we, I mentioned earlier in this earlier on about the evolution of AI starting in the 60s and late 60s, I think it was. One of the challenges that I've seen, obviously would love to get your comment on it, is understanding the nature of the problem. And in the suite of technologies and algorithms available, how do you decide which suite of algorithms apply to that particular problem? So that's one of the biggest challenges that I see is I've got this X problem. Which out of the suite of things that I could use for that are the right thing to use to solve the problem?
Yes, this is indeed a major problem. So what you're referring to is called model selection in the jargon, choosing which type of model to apply. And it comes along with a slew of other questions. So, for example, each one of the characteristics that you see in your area, it's called a feature. Now, if you measure it in the real world, it's a raw feature, and if you combine them in some way to come up with a new feature that you don't measure. It's a synthetic feature. And so feature engineering is actually a quite big topic. Generating new features, selecting the ones that are most informative about whatever you want to model. And these decisions, which features, which model, and then which of these famous hyperparameters to choose to get the model that you've chosen to model correctly, all of these are choices. State of the art currently is that these choices are made by people. So it's guys like me who sit down and say, I think we should go for a neural network with 3 hidden layers and 20 neurons in the third layer, and so on. And then I try it out. And here comes the depressing message to everybody. This is a trial and error process. The science of AI has not evolved past this stage. And so we are stuck at the phase of coming up basically with a list of options to try. We try them all and we pick the best one. It's not very scientific, but that's the way it still is. And it's the holy grail of AI. Right? So if you want to win the Nobel Prize equivalent in AI, this is the problem to solve. Can you come up with a method to decide these questions a priori without experimentation? The advantage of knowing this is that you can automate this trial and error process, and that's something we've done at Samsung. That's kind of our main product offering in the AI department, is to have automated the entire process of decision making. So we have to pay for it in terms of computing infrastructure. It does all the experimentation and so on, but we gain the human time. So we have to put less human effort into the project to do that, but it is nonetheless an experimentation effort. And the final outcome is the best option we found. And there is no guarantee that there isn't a better option out there that we simply didn't try out.
So that's an interesting, it leads us on to an interesting question about the operating model of a business. One of the challenges is, yes, everybody's saying, I want to use AI, but the reality is, how do you think about embedding in models like this? You said there were 20 plus, right? How have you guys thought about embedding those models into the operating model of the company? How do you know, actually, in this bit, we're going to implement this model? What's the sort of thought process and the operating model changes that have taken place to enable that to happen? Because without that, having a model is fantastic. Having some results may be useful, but actually, unless you can figure out the whole value chain from I've got a problem, I've figured out what the pieces are to solve it, and then I'm going to operationalize it. You need all three and a load more that sits around it. How have you thought about on those aspects? So we talked about the first two, but the operationalization. Sorry, horrible word, but you see what I mean. How have you thought about doing that?
Right. So the first thing to realize is that AI is mathematics. So whatever it is that you do, the outcome of this thing is going to be a number. So you have to ask a precise question that is meaningful to you and that is answerable in numerical terms. And if you can do that, then AI will deliver that answer to you. So many higher level executives in industries that I meet say, like, okay, I want to use AI to make our business better, or more profitable, or faster, or something like that. And that's a very loosey-goosey way of approaching things. And so you will be disappointed if that is your KPI. But if you go in and say, okay, I want to calculate how many units of this product can you sell in that store in the next 4 weeks, the outcome is a number, and that number is either correct or incorrect. That's a very suitable problem to pose to an AI system. And then you can gather the data of how many units you've sold in the past at each one of the stores that you have, and so on and so forth. And you can train the AI, and you can talk about how accurate and how inaccurate that model is. You can track it over time to see, does it perform in the wild? And then, of course, you also have a business case, right? If I predict correctly, then I have so many fewer stockouts. I have so many fewer sellouts. Each unit has a certain internal cost. Each unit has a certain value to the market, a revenue potential. And I can calculate what that means in financial terms. And then I can say, this model is worth so many millions of dollars worldwide in extra revenue or in saved internal costs. And then you can go to C-level and say, okay, it's going to cost us $1 million to make and deploy the model. It's going to save us $100 million a year in costs and extra revenues. Is it worth it? Hell yeah. And therefore, we're going to do it.
Interesting.
So it starts with a precise question.
Making it, putting it into operation. So yes, you've come up with the model. How do you then think about changing the operating model of the business to embed that into how the business works? So, yes, the data scientists will have come up with the model. Yes, you built it. You've got the data coming in from your ERP systems and logistics systems and other things coming in. And that's a whole different question of how you do that. How do you take that and say, right, I'm going to embed it into the process? When do you embed it? How do you know where to embed it into the process? And how do you know, do you say, I rely on the 100% guy, actually it's going 100% accurate? Because people sometimes go, well, AI, I don't know if it's going to be accurate or not. So how do you then, what is I want to embed this into my business. How and where do I embed it? And how do I know how to do it?
Yeah. That is really complex and an excellent point. So really you have two streams, right? The one stream is the technological embedding. You've got to make sure that the model is fed the data in the live stream so that it can actually make these predictions at the right moment. And then you've got to implement a pipeline for the model predictions to get to wherever they're supposed to go. So let's stick with that retail example. So the model needs to be fed the information about what is sold where at what time at the current moment. It needs to be fed data about the manufacturing availability, how many units can be produced, how many units are currently on stock at the manufacturing plant, things like that. That's a computer interface. The second interface is you need to communicate back to your supply chain people, but these are shipping orders. So basically the software automatically generates shipping orders, right? How many units are going to this address? How many units go to that address? And it's the usual way what also like Amazon warehousing does, right? If you type in an order to the system, it automatically prints like labels and shipping lists, and then people just put the stuff in the box, stick the label on, and send it off. It's the equivalent of that in a larger segment where you don't have packages but trucks moving from A to B. But the really important part is the change management of the people. So the techie stuff is just work. You implement the software interfaces, no problem. But you have to get the people, and of course we're talking about many people, right? We're talking about potentially thousands of people distributed worldwide who have to somehow adopt this new automation process. So they have to be educated about why we're doing this, about how exactly it's going to work. And most important of all, the number one question, this will not put you out of work. Don't worry. This AI will not fire you. It will actually help you make your life a little better. And here are the 20 reasons why. That is really the absolutely crucial part. So I see that about the vast majority, maybe 80%, maybe even more, of the AI project failures are failures due to change management, where the people at the end who are actually supposed to use the AI, who are expected to change their style of working, for one reason or another, refuse to do so. That is the major risk factor in deploying AI in a real business.
So the question comes, you said you talk to lots of companies outside Samsung. What is the maturity of understanding that is what they're going to have to do? The change and the business process change work that needs to happen is crucial on making this implementable. I know for one of the cities I know from that I've heard in the market is only 1 in 10 models that ever get into production. So if you imagine 9 out of 10 never get into production. Now, is that, so the question is it the 9 of the 10 models in quotes wrong? Or is it because they just haven't been able to productionize them well?
Yeah. So in my experience, it's very rarely the mathematics that goes wrong. In some rare instances, of course, you don't have enough data, or your data is so noisy that it doesn't have the information in it, or whatnot. But these cases are very rare. And if they occur, it's pretty obvious very early on in the process that is the case. And then you immediately kill the project because you don't have the data to do it. In virtually all cases, the models are fine. They are accurate, they are performant, they could be deployed without any real hiccups. It is the people process at the back end. So the real problem with AI is convincing the people to adopt it. In some cases, of course, the problem is with the business value, right? There are AI systems where the cost of the system is roughly comparable to its business benefit. And then it's fair enough for senior management to say, well, you know what, it's a wash. We're going to leave it. But that's not very common. There are cases like that. The far more common case is you have a great model, it has a very good business case, but the people in the process, for one reason or another, say, never mind.
Interesting, yeah.
And that's the 8.5 out of 10, and the other couple
yes.
of cases are maybe the 0.5 out of 10 case.
Yes. So recently in the news, we're talking about we're talking about advanced AI models, and I think NVIDIA just released an article saying that someone somewhere out there is going to spend $1 billion on training and running models. Now, I'm sure that if you talk to the Facebooks and the Googles and the Ubers, they've probably already spent, I don't know if they spent $1 billion, but they will definitely have spent a humongous amount of money implementing those models. I mean, what do you think about the cost of implementing, the whole life cycle of finding the model, creating the model, implementing the model? Do you think that NVIDIA's comment about, there will be in the future, near future, that somebody will spend $1 billion in the model, but actually it will generate a $10 billion revenue opportunity? Do you see that?
I do. Yeah, I do, especially on the cost side. So it is particularly natural language processing that generates the high cost. So we recall a couple of months ago, the model GPT-3 was released. That's a natural language model. In other words, if I say a sentence, the model will say a sentence back to me that is, in some sense, a meaningful conversation. So the applications here would be like chatbot type applications, where today you might visit a website of, let's say, a car manufacturer, and do you have questions? I type in, okay, do you have a model that has this? And then the reply is not from a human being, but the reply is from a chatbot. And it's natural language model that generates that response. So the most sophisticated one is this GPT-3 model that came out a couple of months ago. And it reputedly cost $5 million to train once. Now, what is that cost? That cost is the amount of rent fees to rent the hardware infrastructure for a certain period of time, the couple of months that it takes to train the model, and the electricity to run that hardware for that period of time. If you were to purchase the hardware instead of renting it, the cost would be far higher than $5 million. So if you were to build a data center of your own that you buy and physically host somewhere, the cost might be more like 100 million. And that's the entry level ticket to begin, right? So then you have your data center, you do the training, and then you have the model. But of course, that has no benefit yet. Now you have to use the model actively to generate what are called inferences. So when I say a sentence, the model then calculates its response and gives it back to me. That's one inference. Now, a single conversation with me might have 50, 100 of these inferences if I keep talking to the bot, right? I keep asking questions or I keep responding. So that means I have to execute the model multiple times to have a conversation with me. Now, if I deploy that on the internet, I'm going to have a large number of simultaneous conversations with many people. So I have to, again, have this data center operational 24/7 to do that. And we see that today about 70% or so of the worldwide data center architecture running on AI is deployed on recommender models. Recommender models are, for example, the thing that tells you what movies to watch on Netflix, what to buy on Amazon, which news articles to read on Facebook or LinkedIn. And every time that you refresh your Facebook feed or your LinkedIn feed, or you click the home button on Netflix, the recommender model is run again. Right. And of course, it does that for the millions upon millions of people throughout the world who do the same. So there are huge data centers entirely dedicated to running that recommender model. And that generates costs like this in no time.
So picking up on that topic and extrapolating about different industries, we've seen, we talked about, you mentioned Facebook and there's a bunch of other ones. We've seen the manifestation of the adoption of AI, what the result is these $1 trillion companies. Some of the industries like Uber, as in Uber, they've done that. Uber isn't a taxi firm, right? It's a data firm, right? And they just shifted the way that how they were going to do it, which is all based on data. What industries do you see are next, and what disruptive companies are going to emerge in which industries to do what Uber did to taxis? So, I'd love to get your opinion on, why Uber works. Why does Airbnb work? Why are they worth hundreds of billions of dollars? Is it because they just found a new business model? Is it because they figured out how to use data? Is it they figured out how to do better go-to-market strategy? What do you think around that digital transformation of an industry? And what if you have a view on the characteristics you see of what will make the next industry? What pieces, ingredients, and recipes do you need to make the next industry transform?
Well, ultimately, the benefit of AI is an automation of something. So if we think back 2 or 3 decades ago, when we wanted to buy something, we could have either driven to some solitary store out in the village that had what you have, and then drive to the second store, or we could have gone to the mall. Everybody went to the mall. Why? Because it automates things for you. There are many stores in the same location. You drive once, you buy multiple things from multiple stores, and you come home. Then the internet came, and now you can visit multiple stores without having to drive somewhere, and they deliver it. Then Amazon created basically the online mall. You visit a single store and you buy multiple completely diverse items. So the process is successively automated like that. And I think that's why Uber works. Because if I want to order a taxi, the classical taxi, I first have to figure out what is the hotline number for the local city I'm in to call. Then the taxi comes to me that takes time. Then at the end, I have to pay the taxi driver, usually using cash, and then I have to get some change, and this takes time and whatnot. Now, I don't care where I am in the world. I go to my Uber app. It finds me the taxi that's already where I am or very close by, so I save time. The payment is automatic. I don't have to worry about haggling with the taxi driver or getting change or anything. I simply get in and get out. There is no issue of the taxi driver knowing the local area because GPS in Uber takes care of that as well. So it makes life a lot easier by automation. And the same thing with Airbnb. It automates the entire process. I know that Airbnb has vetted this particular location. It's going to have a certain minimum standard. Payment is taken care of. Negotiation is taken care of. Everything is automated. It makes life a lot easier. So you have to think, what are we currently doing as human beings that can be automated away? And of course, the most famous example of all definitely is autonomous driving. That currently represents more than 50% of all the effort that people put into AI and that financially is being put into AI. So more than half of global AI efforts are autonomous vehicles.
Wow, I didn't know that.
And you will quickly have. I mean, this is not in many years. Definitely in this decade, before 2030, you will have both cars and trucks available for mass purchase that are completely driverless.
So
you can imagine.
So the question I have then is people don't talk about the AI part of that. If everybody says Uber is creating a new business model and they've killed the taxi business. So from a business model perspective, the business guys go, yeah, it's great. They've transformed it. But how do you think data and AI played into these companies' business models? How fundamental was it to actually them being able to deliver what they deliver?
To the current offering of something like Uber and Airbnb, I think the principal offering is really to make the exchange between the person who wants to be driven somewhere and the driver who wants to drive somewhere more seamless. AI helps, but it's not the main innovation here. The main innovation here is, in fact, the business model, the marketplace, the existence of that smooth marketplace. AI comes into the game when you've automated the process of driving itself, right? That is the next huge jump. And now it's just the passenger and the vehicle. There is no more driver. Now you have a process that is very, very different from the business model innovation that Uber and Airbnb did.
So I'll have to slightly disagree with you, because if you look at what Uber has done, and if you look at their the way that they're using data across their business, one of the things that they've done is taken data from every single trip and optimize the best route for that trip, optimize the best driver for that trip, optimize the best user experience for the user to book a trip. All of these things are factored in. If you've ever seen any of Uber's models, their graph is amazing. I mean, their graph is enormous. And what they've done is they've taken data from every single part of their business, every single piece, from how many times does an individual open the app and click on 3 buttons to book, as a user experience end, all right down to what kind of drivers do we want, what kind of speed do they need to go to, which route do they need to take, how many hours do they work, and what's the optimum shift that we need to work people, etc., etc. I mean, for me, all of those things have played into making Uber what it is. I think that has been, and people underestimate that complexity. I agree with you. It's business model innovations absolutely happen. I 100% agree. But without some of the things and more that I've described, they wouldn't have been able to do and implement the business model that they have today. And I think this applies to different industries. So that's sort of the follow-on question is, what's next? Which industry is where's the disruption going to happen? Which industry is going to be disrupted to scale? Given the automotive industry, we've already talked about automotive. I think we're seeing that already. But what other industry do you think is going to be the next to be disrupted because of AI and because of how you implement AI?
Yeah, excellent question. So first of all, I completely agree with you about Uber. It definitely, all of these various analyses play into Uber being as great as it is. Same thing for Airbnb. And the one thing you didn't mention is pricing. The pricing for the Uber trip gets automatically adjusted based on a gazillion variables. So absolutely, those aspects play a big role. I think as far as the ordinary citizen is concerned, the next industry is definitely the car. As I said, the autonomous driving. We will have access to, first and foremost, it'll be taxi type cars that will be fully automated. And at some point later in the sequence, we will be able to actually purchase a private car that will no longer need to be driven. I think that's definitely on the horizon. The same thing will apply for things like trucks. It's then not outrageous to think that the same thing will apply to a few other transport sectors, trains and ships and planes and some to these other industries. I think the basic industry, so industries like power generation, like chemicals production, like oil and gas, and so on, that are currently almost entirely manually run. They are on the brink of a huge automation revolution, and the amount of financial potential is huge. On the other hand, for the ordinary citizen, the potential for safety and for the reduction of carbon emissions is very significant in those industries. They are currently a little wasteful. So there I see a huge potential, but you're not going to read about it in the New York Times because it's very much an industry we don't want to look at. But there is huge potential. It is the mining industry, by the way, that has already heavily adopted AI in the last 10 years. So in a large number of mines across the world, we're talking gold mines, diamond mines, rare earth type mines. Most of the process is already fully automated. You can go to billion-dollar mine sites and find 10 people. So that will progress through some of these basic industries as well. We're seeing that construction, for example, has seen a lot of innovation. There are several new companies out there that have constructed a 3D printer at the scale of a house. So you can find this on YouTube. There are videos of them, printing in hours an entire building without any people. It's some of these aspects are happening as well, and that of course will make buildings a lot more accessible, especially in countries where the income levels are low. Will give people the chance to have a better standard of living. So there are multiple industries that maybe we don't see every day that will definitely get a lot of benefit from AI automation.
So we talked earlier on in the conversation about what Samsung had done with AI internally. And I know from our conversations that you're now offering that to customers to get that advantage. Maybe you could talk a little bit about the innovations that you pulled together into the products that you're now offering to customers. Because obviously you guys, as Samsung has spent tens of millions, if not hundreds of millions of dollars innovating internally and implementing these things. It's amazing that now you're going to offer it to customers externally. I'd love to hear a bit about what it is you've taken from all of the learnings and implementations you've done, and how is that now being saying, hey, Mr. Customer, look, we did it ourselves. this is what we can offer you, because we've done this ourselves and we've learned. So I'd love to hear about that. I'd love to hear about, number one, really how you thought actually, we should go and talk to other customers and sell externally, and then a bit more about exactly what it is that you're offering.
Yeah, thank you. So I run the AI department, and within that, of course, our main job is to develop the models. The deployment and so on is then a later task. We've done that heavily within the group, and now we've decided to go external. So it was kind of a pivot from an internally facing group to now a profit center, if you will, to try to address the wider need of the market. And we've developed some methods to make the pipeline of going from I have a data set and a question to the point where we have a good model that has all the scientific certification that you need to get the job done. And of course, we're aware of the managerial and consultative issues to get that deployed. But our main job is to make a good model for a particular use case that we have. And I have some other videos where I speak at length about the process of this. There are multiple stages where you clean the data, you generate some features, you pick the model, you tune the hyperparameters, you do the actual training. So some people believe that AI is like a magic button. You put data in there, and then you press it, and you wait a little while, hopefully minutes, right? And out the other end pops your magic answer. Unfortunately, AI is not like that. There are multiple buttons, if you will, that need to be pressed, and the conversation with the domain experts in the question takes typically a few months, maybe 3, 4, 5 months, and so on. These projects are a little serious. So we have taken AI to automate the process of making AI, right? So it's AI squared, if you will. So state of the art is that the entire process is largely a manual process, where the data scientists are making a lot of scientific decisions along the way and going through this trial and error process. So we have automated the process of making an AI model, and we use AI to do that. In other words, we can produce an AI model in a total duration that is shorter than previously. We can do that using less person hours than you need today. We can do it using less data than previously because we make optimal use of the data that you have. And in some industries, acquiring data is difficult or expensive. And out the other end, we can deliver a model that has a higher accuracy because there are various mechanisms in place that lead to finding better hyperparameters and better model settings and so on. So basically, we can do the same thing faster and cheaper and deliver a slightly better result by automating that whole pipeline of making AI. And that's called the Brightex AI Accelerator. It's available. You can get in touch with us and give it a whirl. And the prime use case is labeling data. So something that I think most people are not aware of is that the very first step of the entire AI workflow, namely labeling your data, consumes 3/4 of the man-hours effort. And so lowering the effort in that one step is already worth a lot in terms of cost of people as well as time, duration. And we've automated that to a large extent. Obviously, we cannot automate it entirely because we still need domain expert input, but we need a lot less of it. And so that's kind of our tip of the spear in the automation of the entire workflow process. That again is available via that tool set.
Oh, that's amazing. I didn't realize that. I mean, it's absolutely, so you guys are at the forefront of AI, basically. I mean, that's that's an interesting thing. The question is, why would you want to sell this to other people?
No, because hopefully they'll pay us to do it.
Well, yes, that would be great, right? So AI, Samsung's going into the AI platform business and AI model business, I guess, right? Which is obviously another business model innovation for Samsung, given the transformations happened over the last 20 to 30 years in Samsung. So fantastic.
Yeah, of course, Samsung is not known for enterprise software, but that's exactly what we're getting into, or what we are into now, is we do offer an enterprise level AI software platform.
Fantastic. So thank you, Patrick, for that journey from the beginning of AI right to the latest, most advanced areas of AI that you're working on. And thank you, everybody who is listening to the podcast today. It's been fantastic to have you listen. Listen again. Our second podcast will be out soon with another fantastic speaker talking about similar things. And if you have any feedback, please comment on the feedback at the bottom of the podcast, or look on our website, theinnovationbriefing.com. And if you have any suggestions for speakers, if you have any suggestions for topics, we'll absolutely love to hear them. And if you want to speak on our podcast, drop us a line and we can think about whether we want to have you on. And once again, thank you, Patrick. And we look forward to continuing our conversation, and hopefully somebody in the future can come back and tell us where it's got to. Thank you, Patrick, and look forward to hearing and listening to you all soon. Thanks a lot.
Thank you very much, Alpesh.
Thank you.